Hi, very good evening all my dear students. How is everyone? Do let me know in the chat section that your HSP is audible and visible to all of you or not. Kids, do let me know. Can you hear me? Can you see me? I'm here with the awesome chemistry session that is being city. Which city? Aromaticity. If I talk about in English, it is known as aroma. But first of all, everyone, do let me know in the chat section what I can see that am I perfectly audible and visible to all of you or not. My dear students, do let me know in the chat section that you can hear me, you can see me or not. Yes, so today I will let you know about this aromaticity. Okay, so Swagatam, welcome back to your Unacademy NEET English channel. Vanakkam, Swagatam, very good evening, dear kids. I want to see, I can't see you. Samuel Raj is writing, I can't see you. Those who can see me, just do let me know, thumbs up, so that I can start this awesome session of aromaticity. Myself, Harin Singh Parihar, chemistry educator. I did my MTech in 2004. Before that, I was MSc topper, gold medalist in 1999. After doing my MSc, I qualified GRF and GATE examination. Kids, for the last 23 years, I have been teaching. I've produced number of ranks, and these ranks because of students' hard work. I was just the positive catalyst. Your Baba HSP group. Those who know me very well, they know that, yes, definitely, kids, that everyone can hear me, see me, that yes, I'm good, creative, Arjuna, Rakesh, Kagaya, Prakash, Mamta. So let's start. Without any delay, let's start this aromaticity. From the very basic, I will let you know aromaticity. This aromaticity, for a compound to be aromatic, it needs just two conditions. It must follow two conditions. What are those two conditions? Let me tell you only two conditions. That is just the basic. Otherwise, I will tell you each and everything in detail. Kids, the trick for this is LCP, LCP and HSP. My name is HSP, so HSP, this is the trick for any compound to be aromatic, kids. Those who know which compound is aromatic or which compound is not aromatic, they must be thinking of what sir is writing so lengthy. Kids, words, any question you can solve with this trick, LCP. In the starting state, I will let you know only these two fundamental things, H for Huckel's rule and P for planarity rule. This LCP is only for tough questions. Whenever the question comes tough, this is only for tough questions. Right now, I'm not going to deal with LCP. Just I will deal with these two things. But my dear kids, let me tell you the full form of each and everything. Everyone say along with me, LCP HSP, LCP HSP. So see to it, what does it mean LCP HSP? What these initials stands for? LCP HSP. L stands for longest. L stands for longest. C for conjugated. P for peripheral. So kids, these three things are really only used when the question comes a tough question. H for Huckel's rule. This you will get everywhere. In any book, you will get Huckel's rule. This Huckel's rule you will see in all the books. Kids, this Huckel's rule. Now, S stands for SP or SP2. Each and every atom of the ring must be SP or SP2. And P stands for planarity rule. Kids, in the very beginning, I'm going to tell you these two rules. One is Huckel's rule, one is planarity rule. So first half is our this planarity rule, and Huckel's rule is going to be the main aim. So kids, let me tell you, for a compound to be aromatic, compound must have one planar ring. Compound, see to it, compound must have one planar ring. Do remember this ring. If there is no ring, compound can't be aromatic. So ring is necessary, kids. Ring is the necessary condition. But that ring must be planar. Planar ring is the must condition. What is must condition, kids? Not only the ring must be planar ring. And compound must have one planar ring with complete delocalization. What is this delocalization? Delocalization of pi electrons. What are these pi electrons? Kids, definitely I will let you know. Don't worry about it that I don't know how to count, how to see the pi electrons. I will let you know. I will also let you know how to decide whether the ring is planar or not. Delocalization of pi electron, and these delocalized pi electrons and these delocalized pi electrons must follow Huckel's rule. Must follow what? Must follow Huckel's rule, kids. Huckel's rule. Now what the hell? Who is the Huckel? It holds, better to say, it holds a hell lot of weightage. This Huckel's rule is really going to play the important role. Now, first let me tell you how to decide this planar. See, how to check planar. Elements responsible for planarity, kids. See to it. Elements responsible for planarity. I will let you know each and everything from the basic, very basic. Kids, I'm telling you each and everything from the basic. Do remember, if I am having any carbocation, this is always sp2 hybridized, and sp2 hybridized means planar. Whether this carbocation is like this, and the adjacent carbon can be either sp3 hybridized or adjacent carbon can be sp2 hybridized. Doesn't matter what the adjacent carbon is. Whether the adjacent carbon is sp3 hybridized or the adjacent carbon is sp2 hybridized, this carbocation will always remain sp2 hybridized. Kids, do remember, carbocations sp2 hybridization is not going to change. But if I talk about carbonyl, see carbonyl, C double bond C, this is one carbonyl, and C, this is one carbonyl. See to it, everyone. If I talk about this carbonyl, its adjacent carbon is sp2 hybridized, so this carbonyl is sp2 hybridized. But this is sp3 hybridized. So this is also going to be sp3 hybridized. Do remember, in case of carbonyl, if adjacent carbon is sp2 hybridized, then the carbonyl is going to be sp2 hybridized. That means responsible for planarity. But in carbonyl case, if adjacent carbon is sp3 hybridized, this is sp3 and it is not planar. It is not planar. Do remember, it is not going to be planar. Now kids, if I am having boron, see the 3 valency, this is going to be sp2 hybridized. Do remember, it is going to be sp2 hybridized. But let me tell you the most important thing, kids, see to it. Really, if I am having carbon, nitrogen, and see to it, everyone, carbon and nitrogen. Now kids, these 2 nitrogens we are provided with. This nitrogen's lone pair is delocalized. Why it is delocalized? Because the adjacent carbon is sp2 hybridized, so it is also sp2 hybridized. But adjacent carbon is sp3 hybridized. This nitrogen is sp3 hybridized. See to it, everyone. This is nitrogen is planar, responsible for planarity, but this nitrogen is not responsible for planar, so this is not planar. So this is all about the planarity, which atom is responsible for planarity and which atom is not responsible for planarity. Now see how to count pi electrons. Counting of pi electrons. See kids, counting of pi electrons. Do remember, everyone, if I say I am provided with 1 pi bond, 1 pi bond means it is made up of, 1 pi bond is made up of 2 pi electrons, 2 pi electrons. So 2 pi electrons, kids. If I say I am having 1 lone pair means 2 pi electrons. If I say 1 negative charge means, kids, 2 pi electrons. Now if I say, kids, let me show you 1 pi bond, 2 pi electron, 1 lone pair, 2 pi electron, 1 negative charge, 2 pi electrons. Now if I say 1 positive charge, that means 0 pi electrons, 0 pi electrons. If I say boron, 0 pi electrons, 0 pi electrons, 0 pi electrons. I hope everyone is able to count the pi electrons, kids. But let me tell you one more important thing, then only you will be able to understand. See, if I say a compound is like this, now this chlorine is having 3 lone pairs, means 6 pi electrons, but at a time, out of these 6 pi electrons, only 1 lone pair, only 1 lone pair, only 1 lone pair, only 1 lone pair means that is 2 pi electrons, only 2 pi electrons can do resonance, It is just like you are having 1 pistol, 1 sword, 1 stick, and suppose you are going to hit your enemy. So at one time you can use only one thing. It's not possible that you are using 3 pistols, 1 stick, this and that, blah, blah, blah. At a time, only 1 lone pair can do resonance. That means this lone pair is delocalized, rest of 2 are localized, they will remain localized. So this is required. These 2 things are really very, very important. Now let's start. Everyone ready? If you're ready, just to see whether the compound is aromatic or not, show me the thumbs up. Let me check it out, how much energy you are having. See, kids, show me the thumbs up if you are ready. Everyone, just to let me know I'm going to start whether the compound is aromatic or not. So let me start from the first compound. Everyone knows that this ring is planar, this ring is not planar, not planar. Now this ring is planar, this ring is not planar. See, this carbon is sp2, this carbon is sp2, but these carbons are sp3, so not planar. No planar ring means can never be aromatic. But if I talk about this ring, kids, this ring, what will you say? This ring is planar or not? So the answer lies yes. All the atoms are being sp2 hybridized, sp2 hybridized. So this ring is planar and it is following Huckel's rule also. Now what is Huckel's rule? I will let you know. Right now I am telling you this is having 6 pi electrons. So it is following Huckel's rule, 6 pi electrons. So it is following Huckel's rule and it is being aromatic. Aromatic. Now what is this Huckel's rule? See to it, kids. Huckel's rule. What is this Huckel's rule? Everyone see over here, Huckel's rule says, mathematically, I could write it like this. Mathematically, I will say 4n plus 2 pi electron system. Now kids, see to it, 4n plus 2 pi electron system. If I keep the value of n to be 0, if I keep the value of n 0, so 0 into 4, 0, 2 pi electrons. If I keep the value of n is equal to 1, 4 1 ja 4 plus 2, 6 pi electrons. Just keep on adding 4 to it, 10 pi electrons, 14 pi electrons. So if any system is having either 2 pi electron, 6 pi electron, 10 pi electron, 14 pi electron, that compound is going to be aromatic. See, everyone see to it. If I am writing a compound like this is the most important compound given in your NCERT. See to it, kids. Just do let me know. This is known as tropylium cation. This is known as tropylium cation. Everyone do let me know, kids. Is the ring planar? Answer me. Is the ring planar in the chat section? What do you think, this ring is planar or not? I won't answer. I won't answer. Is this ring as a whole planar or not? Yes or no? Yes, do let me know. Yes or no? Is this ring planar? Do let me know in the chat section. Is this ring planar, kids? Let me know in the chat section. Hey, where is the Josh? Is this ring planar? Everyone do let me know. Non-planar. Bharat View is saying non-planar. Royal Challenger Bangalore is saying planar. Do let me know, kids. Is the ring planar or not? Planar. Vigyasa, planar. Some are writing planar, some are writing non-planar. What is this? That means you are not able to understand what element is responsible for rings planarity, and some are writing yes, some are writing no. See everyone. Everyone see to it. Everyone see to it. This is attached with double bond. It is sp2. This is also sp2. This is sp2. This is also sp2. This is sp2. And this is carbocation. What I have told you, kids. Carbocation is always sp2 hybridized. So see, all the atoms are sp2 hybridized. When all the atoms are sp2, so definitely this ring is planar. So it is satisfying first rule. This ring is planar. Now let's see, this ring is following Huckel's rule or not. See to it. How many pi electrons are required for Huckel's rule, kids? Just to follow Huckel's rule, how many pi electrons are required? See, 1 pi bond. 1 pi bond means how many pi electrons? 2 pi electrons. 2 pi electrons. 2 pi electrons. This ring is having how many pi electrons, kids? Do let me know. This ring is having 6 pi electrons. 6 pi electrons. That means Huckel's rule is followed. See to it. what I've told you, if the ring is having 6 pi electrons, 2 pi electrons, 10 pi electrons, 14 pi electrons, and so on, keep on adding 4, it is following Huckel's rule. So see to it, it is following both the two rules. So the ring is declared to be aromatic. This ring is aromatic. Now let's consider another example, second example. See to it, everyone, dear kids, see to it, everyone. If I am going to write this compound, everyone, do let me know, this compound is having 2 rings. This compound is having 2 rings. How many rings? 2 rings. Do let me know, is this compound planar or not? Well-known compound. This compound is known as naphthalene. This compound is known as naphthalene. Naphthalene balls. Naphthalene. Do let me know, everyone, fast, quick. I want to see the answer. If the Josh is high, do let me know in the chat section. Hey everyone, this 2 rings are planar or not? See everyone, all they are attached with pi bonds. So anything which is attached with pi bond, definitely that is going to be sp2 hybridized, sp2, sp2, sp2. All the carbons are sp2 hybridized. All the carbons, kids, all the carbons are attached with pi bond, attached with pi bonds, pi bond. So all they are being sp2 hybridized. So ring is declared to be planar. Yes, ring is planar. Now what we are supposed to find out? Once the ring is planar, kids, what we are supposed to find out? Do let me know. Huckel's rule. So find it out whether the ring is following Huckel's rule, Huckel's rule, Huckel's rule or not. See to it, kids. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 pi electrons, 10 pi electrons. Do let me know, this is following Huckel's rule or not, kids. Do let me know. I've told you how many pi electrons? 2. Just add 4. Just add 4 to it. 6. Just add 4 to it. 10. Just add 4 to it. 14. Just add 4. Keep on adding. Just 2. 2. Add 4, 4, 4, 4, 4. You are going to get. So let me know. It is following Huckel's rule. First rule, planarity rule. Second rule, Huckel's rule. So the ring is aromatic. Naphthalene balls are aromatic. So pH. If anyone is following pH rule. Now from today, let me tell you, if anyone is following pH rule. pH rule. What is this pH rule? P for planarity. H for Huckel's rule. If anyone is following pH rule, P for planarity, H for Huckel's rule, then definitely it is going to be aromatic. Now, kids, do let me know. Some tough questions we are going to deal with. See to it, everyone. See to it. This is known as pyridine. A little bit tough question. Little bit tough question, kids. Little bit tough question. Kids, it is going to be a little bit tough question. Why it is going to be a little bit tough? Is it planar? Yes, the ring is planar. See to it, ring is planar. Definitely all the atoms are planar. But if I ask you how many pi electrons are delocalized, then you won't be able to get the answer. How many pi electrons are delocalized? See to it, this is going to be a really game changer. See, 1 pi electron, 2, 3, 4, 5, 6. Now see this nitrogen. This nitrogen is having pi bond as well as lone pair. This nitrogen, let me write down, nitrogen is having pi bond as well as lone pair, Now out of these two, it is at a time it is having two things, pi bond as well as lone pair. Now either the pi bond will go delocalization or the lone pair. Do remember, out of these two, only one can get delocalized. Both of the two can't get delocalized. If you are having two, for example, if I say stick and if you are removing that stick, or you are having two swords and you are going to remove these two swords at a time, that's not possible for everyone. So this nitrogen can't handle two at one time. Either this pi bond will undergo delocalization or lone pair. So always remember, kids, whenever this type of situation arises, always give preference to pi bond, because pi bond, they all are like brothers. Their energy is same. Pi bond energy is same. Pi bond energy is almost same. So that will undergo delocalization, and this lone pair will be out of plane, means will be out of their group, will be out of plane. So it is localized means not doing resonance, not involved in resonance, Kids, it is not involved in resonance. So how many pi electrons are involved in resonance? 6 pi electrons are involved. So it is following Huckel's rule, 6 pi electrons. So this is going to be aromatic, and that's why this pyridine, this ring is known as, what is the name of this compound? This compound is known as pyridine. Pyridine is declared to be aromatic. If you are able to understand this pyridine, why the pyridine is aromatic, do let me know. Yes, by showing thumbs up if you are able to understand. If you are not able to understand, show me thumbs down. Everyone, quick, fastly, do let me know in the chat section if you are able to understand this pyridine, why the pyridine is being aromatic. Do let me know. Yes, if you are able to understand. Yeah, kids, students, everyone, you guys, just show me the thumbs up in the chat section if you are able to understand. If not, just thumbs down. Very good. Pooja, I can see. Very good. Wow. Yes, the fire I can see. The energy I can see. Wow, very good. Now see, kids, I'm going to give you those questions which you won't be able to solve. See to it, kids. Find out aromatic ones. Find out aromatic ones. Aromatic compounds. Find out aromatic compounds. Let me draw this compound. See to it, everyone. Do let me know. This compound is aromatic or not? Is this compound aromatic or not? See, is this compound aromatic or not? See to it, kids. It is having two lone pairs. This pi electron. See, now first we have to find out whether the ring is planar or not. Pi bond, sp2, carbocation, sp2, oxygen, it is having two lone pair, two sigma bond, but one is delocalized, one is localized. Only this will be counted. So it is sp2 hybridized. Always remember, when you are dealing with chemical bonding, steric number is equal to number of sigma bonds plus number of lone pairs. But remember, these lone pairs we will take only localized one which are not doing resonance. So 2 sigma bond 1 lone pair 3, steric number is coming out 2 plus 1, that is 3, so it is sp2. So ring is planar. So how many pi electrons are delocalized? 1 2 3 4 5 6. So it is following Huckel's rule. Now this is declared to be aromatic. How many of you got the correct answer? Do let me know. This compound is declared to be aromatic. Now, thank you, Fatima ji. Thank you. Now see everyone. Now I am going to give you a tough question. See, if I am going to deal with annulenes, what are annulenes? See kids, annulenes are monocyclic compounds, monocyclic compounds with alternate pi bonds, Now, if I deal with these annulenes, before I'm moving towards annuline, let me tell you about anti-aromatic compounds. The most stable are aromatic. Aromatic compounds are most stable. Then non-aromatic. Now see, kids, anti-aromatic compounds are least stable. Kids, they are least stable. Either so they don't exist, or if exist, then only for fraction of seconds. Stability. If I talk about stability, these aromatic compounds are more stable than non-aromatic. Anti-aromatic either doesn't exist, and if exist, then for fraction of second, they exist only for fraction of seconds. Now see kids, let me give you 1 or 2 examples of anti-aromatic compound. See to it everyone. If I draw this compound, this is the smallest annuline. See what I have told you. What are annulenes? Annulenes are monocyclic compounds with alternate pi bond. See, this is having alternate pi bond, 1 pi bond, sigma bond, pi bond. How many pi electrons are there? 4 pi electrons. This ring is planar. Yes, planar. This ring is being planar. Yes, planar. How many pi electrons? 4 pi electrons. So this ring is declared to be anti-aromatic. And what is the name of this annuline? You just count the number of carbon of the ring. We will say it is 4-annuline. You can say it is 4-annuline, kids. Now see to it. If I draw 6-annuline, you know very well, this is the resonating structure of benzene. This is also known as 6-annuline, resonating structure of benzene. So you can say this is 6-annuline, and kids, this 6-annuline is going to be aromatic. You know very well, this is aromatic. Now the story starts. I'm going to write down 8, 10, and 12 annuline. See to it everyone, this is going to be the most important question for examination. Very important for all the examination. Very important, as well as dangerous. Why I'm saying dangerous? Because definitely you are going to get 0 marks for all examinations. All exams. See what I'm going to write. I'm writing 8-annuline. 8-annuline. See kids, this is your 8-annuline. 8 aniline. Do let me know this is aromatic, anti-aromatic or non-aromatic. I am writing 10 aniline, kids. I am going to write 10 aniline. Just find out 10 aniline is aromatic, anti-aromatic or non-aromatic. I am going to draw 12 aniline. See to it. I am going to draw 12 aniline, kids. 12 aniline. This is 10 aniline. Do let me know out of these three, they are aromatic, anti-aromatic, non-aromatic. Kids, do let me know what are they. This is like this. Do let me know. X, Y, Z. This is X, this is Y, this is Z. What do you think? Which is aromatic out of these three? I want to see the answer in the chat section. Muhammad Ayaya, tub shaped. Wow, Friends Gaming, you are really awesome. Kids, let me tell you, they all are non-aromatic. They all are non-aromatic, non-aromatic, kids. They all are non-aromatic. Now the question arises, they are not looking like non-aromatic. Sir, what you are saying? They all are non-aromatic? I think, sir, you have done some mistake. By chance, you have done some mistake, I think, sir. No, kids, no mistake is done by me. They all are non-aromatic. Now, I am going to explain why they are non-aromatic. How many of you want to get the correct answer why they are being non-aromatic? Let me explain you. Kids, if I talk about this 8 aniline, see, if I draw this 8 aniline, and if I am going to prove mathematically, see to it, everyone. This all carbons are being sp2 hybridized, and we know that if anything is sp2 hybridized, what is the bond angle? Bond angle must be 120 degree. If anything is sp2 hybridized, the bond angle is supposed to be 120 degree. That means this bond angle must come out to be 120 degree. Let us check it out whether it is going to come 120 degree. See, kids, we know that this circle is of 360, and how many angles? 1, 2, 3, 4, 5, 6, 7, 8. 360 divided by 8 will come out 8 for the 32. How much is left? 4, 5, 45 degrees. So this angle is going to come out 45 degree. Now let us suppose this is x, this is x. So 45 plus x, the sum of three angles of a triangle should come out to be 180 degree. So 45 plus 2x should come out to be 180 degree. Now 2x should be equal to 180 minus 45. So it will come out how much, kids? 135. So 2x, x and x, 2x is coming out to be 135, but it was supposed to be 120 degree. So this structure is wrong structure. Are you able to understand? This structure is declared to be wrong structure, and its actual structure was found to be tub shaped. This is planar, but this structure is wrong. It's not the correct structure of 8 aniline. So 8 aniline actually is 8 aniline is actually like this. See to it, everyone. 8 aniline is tub shaped. What? Tub shaped. This is the tub and it is tub shaped. Kids, it is tub shaped, and tub can't be planar. It is non-planar, and once the ring is non-planar ring says it is non-aromatic. Do remember kids, non-aromatic. It is very, very important question for all the type of examinations. 8 aniline is what? Non-planar, so it is non-aromatic. Kids, one thing is very much clear to all of you. I think this point is clear. This is also known as SCOT. What is SCOT? Some people used to say, some scientists used to say COT. 8 aniline is COT. COT means cyclooctatetraene. Tetraene, cyclooctatetraene, kids. Okay, now let's talk about 10 aniline. What's the problem with 10 aniline? See, everyone, 10 aniline. This question has been asked number of times in AIMS. This question has been asked number of times in AIMS. AIMS was taking separate examination at that time, kids. So see to it. Everyone, let me draw 10 aniline. See everyone. Before explaining 10 aniline, let me show you something. If I draw C like this, you must have studied in class 10th standard. This C means it's one valency, methyl is going towards right hand side. So one valency, two valency, three valency, so hydrogen is coming toward this side, and same over here, hydrogen is coming toward this side. And once the same atoms are on same side, you will call it cis. Is it clear? This though you must have studied in your class 10th standard. If I draw compound like this, see Z, C means cis, Z means trans. Why Z means trans, kids? See to it. Z means trans. This valency is going toward this side. That means this is methyl. This is your hydrogen. This side it's coming. That means this is your methyl, and this side hydrogen. Now see, this is your double bond. One hydrogen on right hand side, one hydrogen on left hand side. What you are going to say? This is on right hand side, that is on left hand side. Trans, opposite side, same atom, same side, same atoms, opposite side. Now try to find out over here which one is cis, which one is trans. I have given the trick. C, if double bond is making C, that is cis. If double bond is making Z, then it is trans. So if I put my finger over here, what you can see? C or Z? Say what you can see? C. That means this is cis, and cis means hydrogen are coming towards outside. You can see over here, this is also C. You can see cis, hydrogens are coming towards outside. If I put my finger over here, see kids, if I put my finger over here, what you can see? C or Z? This is C or Z? Do let me know fastly, be quick. C or Z? Definitely it is coming out to be Z, and once it is coming out to be Z, that means kids, this valency is going toward this side. Its hydrogen must be coming in. This must be going out. This is C. So hydrogen are going out. This is Z once again. This is going upside. So hydrogen will come inside. And this is going this side. So hydrogen will go that side. These two hydrogens, because of this transangular effect, these hydrogens has come inside. These two hydrogens are going to change the story. Now see how they are going to change the story. When I'm having one sigma bond, see kids, the relation of sigma bond and pi bond should be like this. This is your sigma bond and pi bond should lie perpendicular to this. If sigma bond is going tilted, pi bond will say, oh, wherever you are going, I will remain 90° with you. I am your friend. I am your friend. My dear friend, I will always forming a bond that is perpendicular like this. Now, if these two hydrogens, suppose if these two hydrogens are not over here, then all pi bonds should be like this. And all pi bonds are like this. So electrons should move like this. You know, pi bonding takes place overlapping above the plane, below the plane, and they always lie perpendicular to the sigma bond, and all the pi electrons, if they are doing delocalization over the entire ring, they are going to give planarity, they are going to give stability. Once the pi electrons are free to move over the entire ring, if something is free to move over the entire ring, no one is going to attack easily. But kids, due to this hydrogens transangular effect, these hydrogens has come over here, and you know that two particles cannot be placed at the same place. We can't place them at the same place, means two particles cannot be present at the same position. It's not the wave which is constructive in nature. Particles need space to occupy. So these two hydrogens are saying we can't live together. We can't be present at this place. So one hydrogen decided to move a little bit up, to shift a little bit up. If this hydrogen is shifting a little bit up, this pi bond will go this side, tilted, means it is going to break its pi bonding with other carbons, because other carbons are like this only and their pi bonds are vertical, but this pi bond is getting slanted. And one hydrogen going up, another hydrogen going down, so it will bend this side. So these pi bonds won't be able to show delocalization. So this is known as transangular effect. Due to transangular effect, there is steric inhibition in resonance. So kids, let me write down over here. Let me write down over here. So this is going to come in your examination and you have to write this only. Due to transangular effect, and these things have been asked in the assertion and reasoning. These things examiner has asked number of times as the question, like assertion and reasoning, kids. Assertion and reasoning. See to it, everyone. So due to transangular effect, there is SIR. There is SIR. SIR means what? Sir, ma'am, no. SIR means steric inhibition in resonance. Steric inhibition in resonance. Steric inhibition in resonance. Steric inhibition and resonance. So the ring has become non-planar. So the ring has become, that's why ring has become non-planar. Ring has become non-planar. Gets non-planar. And once anything is non-planar, that is going to be non-aromatic. So this is non-aromatic, kids. Whenever the question is going to come, tan aniline is aromatic or non-aromatic, kids, definitely this is non-aromatic. Is it clear to all of you? With the explanation I have given to you, my kids, do let me know in the chat section. If it is clear to all of you, show me the thumbs up, and if not, just you can show thumbs down. I want to see the fire in the chat section. I want to see the Josh in the chat section. Kids, if you are in class 11th, your Josh must be very high. If you're dropper, don't think yourself to be dropper. Think yourself to be dreamer. you are a dreamer, and by chance, if you haven't got the seat, you are going to get in your dream college, that is Ames Delhi. So the Josh should be high, should remain at the top. I want to see that. Forget your past. Don't think too much about the future. Remain in the present and try to understand. Yes, everyone is going to put a salute for your efforts. Kids, very good, very good. Now see what's happening with. Okay, let me tell you one thing. By chance in the examination you are not able to understand anything, so I am going to give you a trick. First of all, let me give you a trick, awesome trick, that at what time you do your dinner. Just to let me know what's the time. What's the time at which you are going to do your dinner? At 8 p.m. Some of you will say 8 p.m. Some will say 10, and some others will say 12. This time, 8 to 12, is really very tough time, kids. Whether it is the morning time or it is the evening time, it's really a tough time, kids. Tough time. If you are eating too much, you will feel sleepy. And for other kids, in the morning time, 8 to 12, it's really tough time. So we will say 8 to 12 is non-planar time, non-planar time, non-planar. So if you are not able to apply your brain in the examination, if you are not able to apply your brain in the examination, always remember 8 aniline, 10 aniline, 8, 10 and 12 anilines are what? These anilines are what? These anilines are non-planar, and if anything is being non-planar, that means they are going to be non-aromatic, non-aromatic, non-aromatic. So you like the trick? This time, whether this time is the morning time or at the night time, this time is really non-planar, non-planar, non-planar. You like the trick? Yeah. Now let me explain this 12 aniline. See to it. 12 aniline. Everyone see to it. 12 aniline. So this is your 12 aniline, kids. Now see which is cis, which is being trans. Try to find out. This is Z trans, this is C cis, this is Z trans, this is Z trans, this is C cis, this is Z trans. The one who is trans, their hydrogens are coming over here. Now hydrogen will say, oh dear, we can't be present in this such a small place. So due to transangular effect, once again I will write due to transangular effect, there is what? There is SIR, so there is ring non-planar. Once the ring is non-planar, then it is going to be non-aromatic. So it is going to be non-aromatic, non-aromatic. Clear to all of you kids? Non-aromatic. So if this part is clear to all of you, let me tell you some more important things, really mind-blowing things. Let me tell you kids, see to it. Polarity. How to decide the polarity through aromaticity. See, you must have studied polarity. So polarity through aromaticity. Polarity through aromaticity. Aromaticity. This is going to be the last topic. Polarity through aromaticity. See, if I draw a compound like this, two rings are drawn like this. See kids, you can see the two rings. These are the two rings. Now this pi bond is common to both the rings. This ring is having how many pi electrons? 1, 2, 3, 4, 5. 5 pi electron. This ring is having, lower one is having 1, 2, 3. Upper ring is saying, hey, just donate this pi electron to me. This ring is asking, oh, for what you are asking this pi electron? The ring is saying, please give me these pi electrons, then I will let you know what benefit I'm going to get. Okay, dear, just have it, just take it, and let me know. See, by gaining these pi electrons, this ring is having 1, 2, 3, 4, already 4, and fifth one it's on, and 1 electron it has got from this ring. Now it is having 6 pi electrons. You can see this ring is happy. This ring is saying, oh, I'm feeling happy. I'm feeling happier, better than before, because now I have become aromatic. And this ring is saying, oh dear, by losing 1 electron, I'm having 2 pi electron. Even I'm happy. Both the rings have become aromatic. Now they are celebrating that we both have become aromatic. This has become aromatic. That ring also has become aromatic, kids. So we will say this pi bond has free rotation. We will say this pi bond has free rotation. This pi bond has free rotation. Pi bond has free rotation. Free rotation. And kids, if any bond is having free rotation, it will look like this, and this compound will have very high dipole moment. What is dipole moment? If I talk about dipole moment, the formula for dipole moment is charge into distance. So charge got increased, so polarity of this compound increase. This compound is highly polar compound. So dipole moment increase, polarity increase, polarity increase. Now question arises, how the examiner is going to ask question. This question is going to be the game changing question. See kids, examiner will ask question like this. Question, which compound has frozen rotation? Frozen rotation means won't be able to move. Frozen rotation of pi bond. Frozen rotation of pi bond. See to it, kids. See to it. Let me give you the starting 2 compounds. First compound, already I have explained this compound. We have seen this compound's geometry, shape, and the aromaticity, all those things. Now this is your B compound. See to it, everyone. This is your B compound. Now if I talk about this compound, this is your another compound. So definitely answer to you know very well, this pi bond is having free rotation. This pi bond is having free rotation, free rotation, free rotation. So definitely the answer is this pi bond is having frozen rotation. This pi bond's rotation is being frozen. Now question arises, why this pi bond is having frozen rotation? See to it, everyone. Let me explain it on another page, and this is going to be the last question for today. Kids, see to it. If I say any ring, either the upper one or the lower one, because both the rings are same, if they are going to take electron, see how they will look like. These 2 rings will look like this. It has lost, it has gained, and you see this ring has become aromatic 2 pi electron, but this ring has become anti-aromatic 4 pi electrons. Anti-aromatic compounds are highly unstable, and this is being aromatic. You can see the same compounds, one part has become anti-aromatic and one part is aromatic. So this compound doesn't exist because anti-aromatic doesn't exist. So this compound is not having its existence. So we will say no process will take place. This process is not possible. So this pi bond is having frozen rotation. Even I can write delta G is positive for this reaction. That means this process can't take place. Process can't take place. Can't take place. That means this pi bond will remain like this and its polarity is low. Polarity is low. Polarity is low. It's frozen rotation, so it is not going to move. It will not exist as cationic and anionic form. So I hope this is clear to each and everyone. So this was all for today. Now let me give you two questions for your homework. Kids, these two questions are for your homework, and do let me know in the comment section once the video is over. Homework, two questions, and before writing the answer you have to write Avenger, HSP Baba, Avenger HSP Baba, and then you are supposed to give the answer. So first compound is, this is known as furan. You have to find out it is aromatic or not. It is aromatic or not. Aromatic, yes or no? Yes or no? Second compound is thiopene. This is your thiopene, kids. This is your thiopene. Let me draw it perfectly in the right position. How it will look like? It looks like this. This is known as thiopene. Thiopene. These are two compounds, but because you have given very good answers, so let me give you two more questions. This is your number 1, A compound. This is your B compound. This is your C compound. See to it. And this is your D compound. D compound. So how many out of these 4 are aromatic? Out of these 4, question is, out of these 4, how many are aromatic? How many are aromatic? Out of these 4, how many are aromatic? And kids, if your aim is to go to AIMS Delhi, if your aim is to go to AIMS Delhi, then I will give you one more question. If anyone's aim is to go to AIMS Delhi, if your target is AIMS Delhi, then I am going to give you second round question. That was the first round question. This was the first round question, means NEET, any college. So this was the first round, and second round is a little bit tougher. So I'm going to give you one question. You have to find out whether it is aromatic or not. Okay, you can search for it on the internet. You can ask anyone, your nearest and dearest. And next turn, I will explain whether it is aromatic, it is not aromatic, what it is. Definitely I will explain. This compound, this is A compound, one more compound, this is your B compound. This is your B compound. A little bit difference is there. Are they aromatic? Are they anti-aromatic? or non-aromatic. They are aromatic, they are anti-aromatic, they are non-aromatic. So these are the 2 rounds of questions. So good night to each and everyone. Dear kids, if you are having any query, if you are having any question, if you want to say something, kids, I am here, our team is over here to fulfill each and everything which is required for your best rank in NEET 2024, 2025. Kids, do let us know whatever you want from our team. So kids, those who have not hit the like buttons, I want to see before going, hit the like buttons, and if you are new to this channel, kids, do subscribe. It's your channel only. We can't do anything without your josh, your efforts, and if you are going to get the best rank, if you are going to get the good knowledge, everyone is going to appreciate you, and that is going to hold a hell lot of josh, energy, each and everything whatever is required. You know about our Avengers batch. We are going to teach in the same way, and we are going to give more time, because on YouTube we have to increase our speed, because number of students are watching this channel, number of students are over there, so a little bit speed is on higher pace. And in our Avengers batch, we are going to tackle with a lot of problems with a little bit slower speed, so that each and everyone can understand. Kids, bye. So STR is saying, tell my name at least the session. Yeah, definitely. I have taken your name. So God bless you all, my dear students, with all happiness and prosperity, and just focus on your studies. Kids, bye. Good night, and I want to see these answers in the comment section once the video is over, and do let me know whether you were able to understand each and every concept or not. That is definitely going to give me the best idea about today's session, so that I always see the improvement. If my kids are not able to understand, I always keep on improving. So whatever you want to say, write down in the comment section once this video is over. Good night, all the best. See you in next session. Bye to all of you. All the best.